Hello, welcome to the video for experimental probability of compound events. Now, sadly, I don't have a blank copy of that assignment, and my printer is a little bit on the fritz today. So I have to rough it for this one. You'll see what I mean. I can't show you the assignment itself. We're going to simply just going to write out the lesson itself on the whiteboard. So you'll get everything you need, trust me. So talking about the experimental probability of compound events. Here's your definition. A compound event important word, is an event that contains or includes, you can say includes, that includes two or more simple events. Right. Oh no. This one. Two or more simple events. Now, an example of a compound event might be drawing two cards, rolling two dice. In the event of rolling two dice, the first die has no impact on the outcome of the second die. They're independent of each other. They don't affect each other in any way. A card, on the other hand, when you draw a card from a deck and you set it to the side, that's not available to be drawn again. Your deck is smaller and there are fewer of that kind of card to draw. Either fewer of the suit or fewer of the number. Okay? So in that case, we can say that a compound event can include events that either depend on each other, like how many cards are left in the deck, or the events could be independent, like rolling two dice, which don't affect each other at all. So a compound event, I'll write it out. A compound event can include events that depend on each other on each other or are independent. Okay? Events that depend on each other. So, drawing two cards or more, right? That can affect the first card can affect what the next card will be because they can't both be the same card. Every card in a deck of playing cards is unique. So they can either depend on each other or they can each be independent, like rolling two dice. Maybe some other examples might be a meal and the sides, right? So maybe if you think of a restaurant like Chick-fil-A, which has fried sandwiches and grilled sandwiches, You'd expect that somebody who orders fried sandwiches wouldn't care as much about getting a healthy meal, and a grilled sandwich might be somebody who's more on a diet or cares more about eating fewer fatty foods. So if they're ordering one of those two sandwiches, that might impact their likelihood of ordering either fries or like a salad or fruit, right? I'm not going to say that everyone who orders one will order fries or order like a salad or a fruit salad, but you will notice a larger trend because, there's patterns to behavior. So that's a thing that's kind of a big deal. If you ever go into marketing, if you ever go into advertising, if you ever own a business, you're really going to care about how likely people are going to do things based off of their previous behavior. Okay? So let's look at the next question. It says, the table below shows the customer's orders of lunch choices from Mary's Diner. What is the experimental probability the next order will be a turkey sandwich with chips? So my table, we have, I'm going to abbreviate here, a turkey sandwich and a ham sandwich. And that comes with either chips, a cookie, or fruit. Okay? Now we have, if you order the turkey sandwich, all 25 people order the turkey sandwich with chips, 30 people order the turkey sandwich with a cookie, and 15 people order the turkey sandwich with fruit. Now, 30 people ordered the ham sandwich with chips, 25 people ordered the ham sandwich with a cookie, and 20 people ordered the ham sandwich with fruit. Now, in all, they're all separate orders by separate people. If you add these up, 25 and 25 is 50, 30 and 30 is 60, 50 and 60 is 110, plus the 35, there were 145 customers. And we want to know, out of those customers, what is the likelihood the next order, if the same patterns are consistent, what is the likelihood the next one will be the turkey sandwich with chips? So that's the turkey sandwich with chips, which is 25 people. So your likelihood will be 25 out of 45. Okay? Now we're going to take that fraction, the 25 out of 45. Not 45, 145. And we got to simplify that fraction. So 25 out of 145. Both these numbers divide by 5. So 25 divided by 5 is, you guessed it, 5. 145, well, divide that by 5. 100 divided by 5 is 20. And 45 divided by 5 is 9. So 29. By the way, that's not a 1, that's 100. So we have 145 divided by 5, that's 20 and 9. 29. So that's my answer. There in the bottom corner. Alright, so that's experimental probability of compound events. We're looking at multiple events and how they line up and what the probability of those combination of events could be. Anytime that you see an ad or a recommended video, that's built off of the combination of many different events of Google or YouTube or Facebook trying to figure out what thing would you like to see next. And that's based off of a lot of different data that they use to inform them, their decisions of what's the probability that you'll click on this link, watch this video, click through to this ad. What is the chance that you will, do what they show you, right? This kind of stuff is all over the internet in terms of how it's built. Okay. YouTubers think about this stuff all the time, or at least their marketing coordinators do. If you're going to start out, I mean, you don't get one of those things out of the gate, right? You got to build up to that point. So, look at the number 1. This is the current order summary for Rachel's fast food restaurant. What is the experimental probability that the next order is a hamburger with a side of onion rings? Now, we have this table where someone orders either a hamburger or a hot dog. Lots of food here. And with that hamburger or hot dog, they may order the following things. I'm going to have to abbreviate this. French fries, onion rings, fruit cup, or yogurt. Right? So those are the 4 things that could be ordered. And we see that we have 43, 21, 12 and 34, 22 and 23, 55, 30. So we want to know how many total orders there are, and we're interested in the hamburger with the side of onion rings. So find the total number of orders. 43 and 21 is 64. That's 46. That's 45. And that's 85. So total is up. You get 110 plus 130, which is 240. So we have a total of 240 orders. That is pretty much the fastest way you can add these together. The fewest operations. Alright, so out of the 240 orders, we see that 12 people ordered the hamburger with onion rings. To simplify, I'm going to show you a little trick. If you already watched the probability of simple events, you've already seen this trick, but I'm going to show it again. You write 12 and 240. Think of a number they both divide by. I don't know, how about 6? I could pick a big number. So they both divide by 6. That's 2. 6 divided by 240. 240 divided by 6 is 40. So that's 6 times 40, 6 times 2. And then that divides by 2 again. So 2 divided by 2 is 1. And 40 divided by 2 is 20. So 1 and 20, that's 1 over 20. Okay? So my answer is 1 out of 20. That's a 1 there, by the way. Right? I might have written it a little bit differently, but I kind of want to try this way out of showing it here where there's the matching numbers. You could have picked 12 right away, because they do both divide by 12. Which is also 6 times 2. So yeah, this should always work. I know it always works. So 1 out of 20 for number 1. For number 2, we see below is a summary of the sales and orders from Don's t-shirt shop. What is the experimental probability that the next order will be a long sleeve shirt with a flower design? Now, you look at our table, we see we have a short sleeve shirt and a long sleeve shirt with the following designs. There's flower, frog, rodeo, and music. Flower, frog, rodeo, and music. this table. Numbers are 30, 18, 32, 20, and 16, 23, 26, 11. So we add them together. 46, 41, 58, 31. Add each of these, we get 87, and 89. We get 87 and 89, we get 176. So that's the total of orders. Again, they're all added up. So we added, and combine those totals, and found ourselves with 176. So there were a total of 176 shirts in the order, and we want to know about the long sleeve shirt with the flower design, of which there were 16. So that's my fraction. 16 out of 176. Now, to do this, we have 16 and 176. They probably both divide by 2 for sure. Okay, and 16 divided by 2 is 8. And you do some long division, that comes out to 88. Oh, that's cool. 8 and 88. So those probably both divide by 8. So that's going to be 1, and that's going to be 11. And then we have those simple fractions, 1 over 11, which is my answer. 1 over 11. Okay? Again, you just pick a number that divides both of them. Here we see they're both even, so you pick 2, and then we get 2 numbers that come out of it, 8 and 88. They both divide by 8. What's left is 1 and 11. Now, last question. This one's a bit of a doozy. Below is a summary of Smith Department Store's sales of 3-ring binders. What is the experimental probability the next customer would purchase a green 2-inch binder? So we see 1, 2, 3, PG are yellow. It's a big table, so I'm going to really abbreviate things. So we get 58, 26, 49, and 32. We get 72, 64, 32, 48. We get 34, 16, 27, and 22, I believe. Yes. So, again, a lot of numbers. You're going to add them up. And I'm going to save you the time and tell you they all add up to 480. Right? You can test for yourself, but you'll find that it's true. It's nice practice. But it comes out to 480. Now, from here, to 480, we see in our table we wanted to know about the green 2-inch binder, of which there were 72. No, 64. Maybe that was wrong. 64. So 64 out of 480. Now let's set that up. Let's pick a number they both divide by. I see an 8, and that I think that also divides by 8. So I'm going to pick 8. That's 8 times 8, and you'll do some math and find that's 120. No, not 120. 60. Yeah, because 8 times 6 is 48. So 8 times 60 is 480. So 8 and 60. And I know that at least those both divide by 2. And that gets 4 and 15. No, 30. 4 and 30. Oh, they're still both even, so we'll go another 2. So that goes to 2 and 15. And 2 and 15 have no more common dividers. And so my final answer is 2 over 15. I think about what to call this. Maybe it's like a Christmas tree, which is nicely appropriate. Doesn't it kind of look like a Christmas tree? I think it does. So 2 over 15 is my answer, and that is my probability, 2 out of 15. Okay? Well, that's the last video I'm doing today. That should cover all the assignments. The rest, the only thing I haven't done here is the do now questions. I want you to do that yourself, and the test. You gotta get that in. It is a test, but most of you have that done. But anyway, thank you for watching. Don't stress yourself out too much, and have a good weekend.